Hello students, this is the question which is based on impulse and momentum. Now this is the question which is being asked from one of the student. Based on that I am solving this problem. Okay, so question is a ball of mass 100 grams, it's a gram, is moving towards a bat with a velocity of 25 meter per second as shown in the figure. So this line is basically exactly horizontal. It's not inclined or it is not bit bended. It is exactly horizontal. When hit by a bat, a ball attains a velocity of 40 meter per second. After rebouncing, it attains 40 meter per second. If the bat and a ball are in contact for a period of 0.015 seconds, determine the average impulse force exerted by the bat on the ball during the impact. Now, for this particular problem, this diagram is given. Now what we will do is, the very first we'll resolve this velocity. We'll resolve this velocity, which is 40 cos 40, as even this is 40, this is 40, this is 40, and here I'll be writing 40 sine 40. I hope this you are knowing how to resolve it. Wherever there is an angle, that side becomes cos. Okay, so now we'll start with the solution. Okay, now the data is given as mass equals to 100 grams. If I need it in the terms of kg, then I'll be writing 10 to the power minus 1. Similarly, the time which is required is your 0.015 second. Now here we'll find out a change in velocity. So change in velocity is basically what? Final velocity minus initial velocity. So here we will represent that change in velocity in this way, and that also will take it along x. So along x, this is moving right side, so it is taken as 40 cos 40 minus initial. Initial is moving on left side, that's why it is taken as minus 25. 40 cos 40, which is final velocity, minus initial velocity. This negative sign is just because it is moving on a left side. With this, we are getting delta Vx equals to 55.642 meter per second. This is the velocity which is along x. As it is inclined, so we have to find out for the y as well. So delta Vy is equals to final velocity, which is 40 sine 40 minus initial velocity. But here there is no y direction velocity, only x direction velocity is there, hence it is taken as 0. With this, we are getting 40 sine 40 as in delta Vy. Now we'll take the resultant of these two velocities. That two velocities, as in a delta V is equals to root of delta Vx square plus delta Vy square. In this, if I'll substitute this values, which is 55.642 square, this value, and then 40 sine 40 square, if I'll solve this, I'll be getting 61.295 meter per second. That is for the delta V. Okay, now if I'll go with an average impulse force, as it is being asked in the question, determine the average impulse force. So we are finding out average impulse force. The force has a formula m into a, which can be written here as an m into delta v by t. So here m is your 1.0 into 10 to the power minus 1 into delta v, which is your 61.295 upon the time is 0.015. With this, if you solve this, you'll be getting 408.63 Newton. That is your average impulse force. I hope with this you are clear with the solution of this particular problem. Thank you.